Okay, so you just watched the video on this sequence that we studied. What did you learn?
Oh, well, I guess we learned why that the graph suddenly levels out at some point and starts going in 3 lines.
Okay, why did that happen?
Oh, well, it started around 638 when that was the first time an even number at the top had a 1 down at the bottom, and then started a repeating sequence.
Mm-hmm. Okay. Do you think we'll be able to understand why an even number equaling 1 will lead to a repeating sequence?
Yeah, I think so.
Yeah, I think so.
It created a pattern which just cycled through 4 types of numbers.
I think we can probably write it out.
Okay. All right, let's do that. So it cycles through 4 types of numbers?
Mm-hmm. You get 2 lines, and then the bottom line is actually 2 lines.
Oh, was it? Okay.
It was 1 and 2.
Oh, neat.
So 638, 639, 640. Let's see. So we can just do it for these. So if we get 638, which is 1, and then he called 639, I think he called it M plus 1.
Okay.
And since these don't have any common factors, you do the first formula.
Alright, so what do you get?
So we got, this number is 1 plus 639, which is M plus 1, plus 1.
Okay.
So we get
You can just write out what the number is.
Okay. So we get 641.
Okay.
And then these two don't have any common factors, so we have to, so we get 1, 2, 8, 2.
Alright.
And 641 is now a common factor, so we have to divide and we get 2.
Alright.
And then for 642, 2 is a common factor, so we divide and get 1.
Okay.
And the sequence will repeat, because now we have another even number with 1.
Aha. Okay. Do you think you can do this explanation in general?
Yeah.
Okay.
So
do you have the eraser?
Yeah.
So let's make this be 2, let's call it 2n.
Alright.
And then we'll do what will these next numbers be?
Alright. It's 2n plus 1, 2n plus 2, 2n plus 3, 2n plus 4.
Okay. So what happens when we have an even number where our sequence equals 1?
Well, we start off, we get our next number, and since this is 1, we don't have any common factors greater than 1 with this number. They're relatively prime.
Okay.
So you get 2n plus 1 plus 1 plus 1, so 2n plus 3.
Alright.
And then this is 2n plus 2.
2n plus 2, okay.
So since this number is 1 more than 2n plus 2, we don't have any common factors again.
Ah, okay, so that's an important point. So why can 2 numbers that are 2 integers that are next to each other not have any common factors?
Well, so if you look at the first number, except for 1, if the first number is divisible by 2, you have to, the second number is skipped by multiples of 2. If it's divisible by 3, it's skipped by 3, and so on.
Good thinking, yeah.
So this is 4n plus 6.
Alright.
So you have 2n plus 3 plus 2n plus 2 plus 1.
Okay, good. Let's make sure
So
that little straight mark makes that 2 kind of look like a 3.
next we get 2n plus 3 is our next number we have to look at.
Okay.
And this is twice this. So we have to divide out by 2n plus 3, so we get 2.
Alright, nice.
And then we have to divide again because 2 is a common factor. We're doing 2n plus 4 and 2. So we get 1.
Okay. And how do we know, can you tell me how you know, once we've done it out like this, how you know this is going to repeat forever?
Well, we started with 2n, and then we end up with 2n plus 4 as the next one, and that's still going to be an even number, so
Yeah.
again, it'll go to 2n plus 3, or no, it'll go to 2n plus 6, and then 4n plus 12, and then you can just keep,
Where's the next one going to be?
at 2n plus 8.
At 2n plus 8, yeah.
So the numbers, these two numbers don't stay the same, but they stay in a similar pattern.
That's why the lines go up.
You're right, that's where the lines go up. Yeah, so this is really a neat surprise. So you have a very simple pattern here. Do this if there's no common divisor, do this if there's a common divisor. And it looks pretty random
Mm-hmm.
for the first, well, whatever it was, 630 something
Yeah.
entries. And
630 this is the 638th entry.
Yeah.
then all of a sudden, boom,
Goes into lines.
not random anymore. So that's pretty neat. That was a fun thing to learn about.
Yeah.
All right, good work today, guys.